Welcome back. In part two, we're going to add the conditions to our part one uh, player character status window over here on the left hand side of the screen. If you haven't watched the previous video, you may want to watch that to get to the point where this one starts and we start adding conditions. So before we jump into the editor and I'll show you the finished product, let's talk about the macro design first. Our design is built around the gameplay effects, and gameplay effects can be applied to the gameplay ability system, which in Lyra is attached to your player state. Your player state has a Lyra ability system component on it, and that's what handles all of the ability activations, the gameplay effects. It also handles your gameplay cues, and I will let you know that I tried to do this with gameplay cues at the beginning and ran into a problem that gameplay cues are one directional and they did not have a couple of functions that were necessary in order to pull stuff off the UI at the appropriate point, particularly in our infinite duration conditions. So the way this is working is we have a series of environmental actors. You'll see water, lava, and poison. They're just actors in the world that will apply and or remove various gameplay effects when the player overlaps with those actors. And then all of the logic, whether it's applying damage, dealing with some of our survival attributes that we did on the last video, those are all triggered from within the gameplay effect itself. So that is doing all of the work. On the UI, what you're seeing on the UI is completely cosmetic. It's there to allow the player to see when things are on them and when they're going to expire. But the actual expiration is driven by the gameplay effect, not the icon on the UI. And the way we're accomplishing that is we've hooked into a broadcast node inside the inside the Lyra ability system component that will broadcast changes to tags. And it is the tag that is the important part of the system. When the tag changes, we pick that up in our HUD and we're able to process it. So when we do jump in and start looking at the code, the character status window is the C++ window that we dealt with in the last video. In this video, we're adding the new active conditions widget, which is a C++ file you can find in the description, as well as the condition icon widget, which is also in the zip file in the conditions. So let's go see how it functions, and then we'll walk through some of the setup elements. So let's start by seeing how our conditions are functioning, and then we'll go into how we set it up and then into the code. So if you remember from our last video, we were working on our hunger, thirst, stamina, and smell/clean. And now what we've done is we've added a number of conditions that the player can get introduced to. So let's go into the water. You'll see as the character goes into the water and starts swimming around, the dirty smell is being washed off. And I have a positive condition, that little island condition, indicating that I am in water. And then as I exit water, you'll see that the condition shifted from the palm tree to what we're calling is wet. So my character is still wet, and then that expires. And so if I go into the water again, I'm in the water. I come out, I'm still wet. If I go back in, the condition is reset. And let's go do some other things. So here we have some lava pool. which, as you'd expect, as I go into lava, I'm going to take damage. And then as I exit, I continue to take damage just like the water. But if I am taking damage and I go get wet, I can get here fast enough, then the burning stops. In this poison pool, we don't actually, in here, we instantaneously start taking damage, and we continue to take damage while we're in the lava. And if we step out, we trigger the burning. For poison, we're actually applying stacks. So you'll see our poison stack increasing. And then as we exit the poison stack, you'll start to see the numbers decreasing. And poison does not wash off. So unlike the fire damage, any poison damage is still persistent when I go in and out of other volumes. All right, so that's functioning the way we would like it to function. And then we're just gonna let those expire, and we'll look at how we set it all. All right, so the first thing we'll take a look at is the swimming volume, which is a water volume, and I've attached that code to the description of the video, so you can go ahead and just grab that water volume. And the water volume is basically set underneath the plane of the water. It has an active gameplay effect that gets applied when you enter the volume, and it has a residual gameplay effect that is applied when you exit the volume. You also have on entrance tags that you can remove. So here's how I remove burning as well as wet, because I don't want to be wet and in water at the same time. So I have to remove if I'm wet before I go into the water. And then upon exiting, I'm going to remove the in water tag. So this is how the water volume works. And again, that's C++, and we've attached that to the video description. The lava pool isn't that different. The only difference here is we did it in Blueprint. And basically when you overlap, we are firing off every half a second and applying a stack. So we could slow that down if we wanted to make it every second. And we're basically adding the active condition to the character every stack. And this is just some debugging. Oh no, it's just testing. You actually don't need any of that anymore. That's all C++ now. We don't need any of this. So that's our applying stacks, where we, upon overlap, start running this on a loop, and then upon exit, we basically clear that timer. Similarly, our active condition is set here as a variable. The lava pool is not that different. We have, similar to the water, the entrance tags and the active and residual. And then let's start with the U. Let's start here. All right, so there's a data table in the design, and I'll explain that when we get into the code, which is all of the conditions that we want to appear on the UI. So if I open that data table, what it defines is it defines the tag, what the image, the material is for that particular tag, whether it is infinite or durational. Is it a positive or negative condition? So if I had a negative condition, I'd turn that check mark off. And this fetch active gameplay effect for duration is useful for duration-based effects. Like here's where I was testing it, where you don't want to use this duration. So for infinite, there is no duration. For one without the fetch enabled, this is the duration. It's more performant to just hard code the duration for this outline. However, if your condition might be variable, then we set an initial duration just to seed it. And then inside our code block, we go fetch the actual duration from the gameplay effect, which is here. So we could actually set this by collar. And if we set that by collar, we could pass in any number we want, and then we could make this be the duration. Inside this burning one, as we said, it's a duration. It's for 5 seconds. It ticks every half a second. It applies damage. So this is the component for applying damage. And this is what triggers, this gameplay cue is what triggers the visuals on the screen when you're taking damage. And this one is not stacking. However, our poison is stacking to a max of 15 stacks. And so we cap it at 15 stacks and we aggregate based on who that poison is being applied to. Here you see the asset tag poison. And so with that cap of 15, you'll see us tick up to 15 once every half a second. And you'll note that the outline is moving at a pace of around 5 seconds as opposed to, so here you see we're stuck at 15 because that's our cap. And then we're not going to wait, but if we were to get out of the poison, 15 would drop to 14, 13, 12. It just takes a while. So then they start ticking away. Because we're using the poison fetch the active gameplay effect for duration, I could go into my poison duration and let's make it a 2 second and ticking every 0.25. And what will happen is you'll notice the still applying, but the bar is going to be removing every 2 seconds. It's going faster. This is the condition icon material, where we have our background color that is exposed as parameter. We have our icon color, so here you see it's black. We have our icon mask and our outline mask and our outline color. And we basically are just doing some add, multiply, subtracts. That will get us all the way here. And then we lerp this one based on, we take our texture coordinate. This was just a little bit of trial and error to get to the right value to start the custom rotator in the right position. And then you basically follow this. If you wanted to have the outline go in a different direction, you could change it here. You do a vector to radial value change where you take your vector in and convert it out to an angle. This is what controls it, percent remaining. So at 0.5, it's halfway around, 0.25, quarter of the way around, and at 1, it's complete. So that basically just carries that around. And that's the simple material for the condition. Our condition widget is a child of our condition icon widget C++ class, which is included in the description. We have to expose an image file called condition icon and a stack text for the number. So those two are bound in the C++. That's all you need to have in here. And there's nothing in the graph. all done in C++. Those condition icons are loaded into our active conditions window, which simply is a positive conditions horizontal box and a negative conditions horizontal box parented to our active conditions widget. And again, nothing in the event graph. You do, however, in this active conditions widget, need to define what the widget template you're going to be using. That's our condition widget. And then what data table is this widget going to be processing to monitor various conditions. And again, we said that earlier. These are basically the tags and the corresponding images and settings for each of the conditions that you want to show up. Let's take a quick look at the C++ file that are attached in the description of this video. Let's start with our water volume. Basically, the water volume defines the gameplay effect, active and residual. It defines two containers, the entrance tags and the exit tags. It overrides on actor enter volume and on actor leave volume. So these are overridden from the physics volume parent child. And we've defined just two functions to make our lives a little bit easier. In the volume, we basically make it a water volume. And here we're gating or latching that we only process this on the server, and we only process it if the overlapping actor is a character and that character has a player state. So we're making sure that it's a player, and then we're simply just logging out that we're there. Once we know that we have a player character with a player state, we can safely pull the Lyra ability component off of that. We can remove any active effects based on the entrance tags. So this is what removes those tags when you go into the water. And then we can add our active gameplay effect. The leaving is the reverse. We basically also check our gates. If we're good, we have just one more check here, which is I may be nested inside multiple volumes. So I might have a water volume that overlaps with another water volume. And though while the character left one water volume, they may still be inside the other water volume. So this is just a check to make sure we have no overlapping water volumes. If that's the case, we will remove the active gameplay effect, and that adds the residual effect, which you'll see here and here. So the water volume is fairly simple. The magic starts to happen here in the active conditions widget. So in the active conditions widget, we have our enum defined for the two types of conditions. And we have our F conditions struct, which will be the base of our data table. In that, we have the condition tag, the condition material, the mode, the duration, whether it's positive or negative, basically all the elements that we just saw on screen. We bind to the two horizontal boxes in the designer. So this is what binds the two boxes you define in your UMG widget. And we have our variables. And then this is the important callback routine. So when let's go. When this widget is initialized and placed on the screen, first thing it does is make sure all parent initialization is done. We make sure that we have a condition data table and that we can get the owning player. So we get our player state, we get our ability system off the player state, and then right here, we loop through every record in the conditions data table and make a gameplay tag and register that we want to be called back anytime that tag changes. So each of the tags in the data table will spin through this for loop and will create a callback routine to the exact same function. So all tags called this function. And that function will be past the gameplay tag, and it gets past this new count. Now, this is not the number of stacks. It is not. It's always 1 or 0. It means a new one was added, or the last one was removed for 0. It took a little bit of testing to figure out what was coming in on that variable. When we get a new tag, we go ahead and get the condition record out of the database again, and we pass that record to the apply condition icon, which is here. We make sure that we have a widget template, because if we don't, we won't be able to create widgets. We search the positive and the negative horizontal boxes to see if that tag already exists. And so resulting of whether we found a condition or not, if we found a condition and the new count is now 0, we're going to remove it. If we found a condition, it was already in the horizontal box, then we're going to update the stacks, because it means a stack counter has changed. If we didn't find it in either the negative or positive horizontal box, then we go down here and actually create it. And so because these two returns here would kick us out, if we fall through this, we create it, we initialize it with the initial material inside the widget, and then we add it either to the positive or negative horizontal box. So that's all this is doing, is it's look, if the target condition was positive, put it in the positive. If it was not positive, put it in the negative. And on the remove, we basically just find it and remove it. We remove from parent. Same for positive, same for negative. And our find is basically just looping through. There are not that many, so looping through is not that difficult. And we're just getting the condition tag from the widget and comparing it to our condition tag that we passed in. And that's it for this class. So the important thing in this class is that it is setting up to listen for the gameplay tags. And so when the gameplay tags change, that's what triggers all the rest of the logic. That logic is all contained here inside of this widget, with the exception that our individual icon, which has the image file and the stack number that you see on screen, we basically have a couple of things that are happening in here. We have our initialize, which we call upon creation. That passes in all the data, sets up the widget appropriately. We have our update stacks, which we call whenever we get a new modified tag. And then we have to, once we have a new stack number, we put it on the screen with this update stack counting UI. And then we're using a timer to basically simulate the outline going around. So a couple things that are probably pointing out here is we do our initialization, we set all our variables, we either set it to be a perpetual condition where it's infinite, or we set a timer to start looping through the duration. We create our dynamic material. We're using the parameter percentage remaining and setting that scalar parameter. And then as we update stacks, we have to go and get the number of stacks. So what we're doing here is we're saying, okay, when this comes in update stacks, it means the stack was updated, but I don't know whether it was positive or negative. So we need to go get the active effect with this tag. When we get that, we're going to get the current stack count from that result, and then we're going to basically update our stacks with that new current stack count, reset our timer to the original duration, so it's 100% again, and then we update it on the UI. Updating it in the UI is pretty simple. We just simply say, look, if I'm a stack of 1, I don't need to see that. So 0 and 1, I don't need to see it. Anything greater than 1, we'll just create 2, 3, 4, 5. Here we're running off our timer, which is causing the outline to tick down. And we're basically just setting the scalar parameter. And then here's our ticking condition, which is got the fetch logic in it. So if the first time we come into the tick, if we have not yet fetched, but we want to fetch, we will go get the gameplay duration off of effect and then make the adjustment here. And that's it. So those are the files that should be attached. Leave a comment if you think I missed something. I tried to go over it fairly quickly, but also to provide the source files so you could read them at your leisure. Thanks for watching.